So at first, welcome again to join the second day training. And before we talk about today's topic, let's have a brief review of yesterday. Because yesterday we talked about three topics, right? Do you still remember? Maybe someone already joined yesterday. Maybe someone today is the first time to come in the training. It doesn't matter. And yesterday we have three topics according to the topology, right? So now I also will share you with the topology again. Our target after this training, we hope you can deploy the simple network like this topology, includes the wired part and the wireless part. And yesterday we talked about three topics, includes the IP address, L2 switch, and the VLAN, right? We talk about three parts because about the basic includes your terminal, maybe your layer 3 switch, maybe your router, or maybe in your network, maybe you have a firewall or something like this. Also, maybe deploy the wireless devices. The first step after you use a cable to connect with each other and to deploy the places and install the devices. Later, we have to give the configuration. The first parameter we have to give the IP address. So yesterday the first topic we discussed something about the IP address. At the beginning, the IP address is be divided into classification address, includes the classification A, B, and C. But in order to more efficient usage of the IP address, later we will use a submask and do the subnetting for the IP address to invite a bigger network, for example, about the classification C address. One segment, we have 256 IP addresses, right? But we hope this more than 200 IP address can use for one company, maybe three departments. So we have to do the subnetting and how to do the calculation and then to meet the requirement. And in this IP address, two addresses is very important. The first one is network address, because network address indicates the segment. Maybe in your router or layer 3 switch, in the IP routing table, you can see the routing entry, and one network address will indicate one segment. So this is a key point. And who will decide the IP address number? It is decided by the host bit. If the host bit is long, that means in one segment you will have more IP addresses for the client, maybe for user, maybe for network devices. But if your host ID part is shorter, that means maybe your subnet ID part will be bigger. It depends several segments you can use. So this is a key point of the IP address. And later, if you have two computers want to communicate with each other, if they have the shorter distance, maybe we can directly use a cable to connect with each other and give the IP address, then we can transfer the message. But if we have a long distance over 100 meters, we will use a new device. This one we call a switch, right? And about the switch, the main function of the switch, we have two processes. The first one, layer 2 switch for the message according to one table. This table we call is MAC address table. This is the biggest difference with the hub, because about the hub, when I receive the message, I will make the signal bigger and then transfer to every port. So the hub cannot limit the collision domain, but the switch can. About the switch according to the MAC address table and then for the traffic out. And in the MAC address table, the main parameter is according to the message source MAC address and connect with the receiving port and add into the MAC address table. And finally, the switch will forward the traffic and according to this table, and it depends on your destination MAC address and then forward the traffic out. So these are two processes the switch will do. And about the action of the switch, we have three parts. The first one, when I take the destination MAC address to match your MAC address table, I will find the entry and the receiving interface is different with the connection interface of the MAC address table, I will only forward the packet to the only interface. So this is the first action of the forward. The second one, if we receive the message is a broadcast message, or maybe multicast message, or maybe unknown unicast message. Unknown unicast message means this destination MAC address not exist on your MAC address table. If we receive these three types of message about the switch, we will do the flag. So that's why we say the layer 2 switch can limit the collision domain, and different terminal can transfer the message at the same time. But the layer 2 switch cannot limit the broadcast domain, because I receive this message, I will flag. In the same layer 2 switch network, everyone will receive this message. So this is the action of the flag. The third one, maybe sometimes the switch will discard the message. What's the scenario? When the switch receives this message, and then I will take the destination to match the MAC address table. When I find the connect interface is same with the receiving interface, in this scenario, I will directly discard the message. So this is the third one. Why to discard? Because we want to avoid the loop. Three actions. So when you choose the devices, the layer 2 switch in your network, you have to consider the performance of the layer 2 switch, how many MAC address table you can use, how many entries you can use. This is the biggest maybe you have to consider, because the entry is more, maybe you can forward the traffic to as the unicast only to the only one interface can be forwarded out. Otherwise, maybe you will do the flag, and finally to waste the bandwidth. So these are three topics. The second topic we talked about yesterday. And the third one, we explained something about the VLAN, right? VLAN is virtual LAN, virtual local area network. And why we use the VLAN? Because when we talk about the principle of layer 2 switch, we found that layer 2 cannot limit the broadcast domain. So if in our network, we have lots of layer 2 devices in the network, every terminal will receive this broadcast message. And for example, if you have 400 terminals in your network and send out the broadcast message at the same time, there are so many resources should be used, right? But actually, maybe only the PC1 want to send out this ARP broadcast message to ask who is PC2 and what's your MAC address. But more than 300 terminal will receive this message, and finally, except PC2, everyone will discuss this message, right? So this is a very big problem in our network. So we also have some solution, for example, to deploy the router or to deploy the layer 3 switch in our network. And then you can use these devices to avoid the broadcast domain, because by default, layer 3 interface will not forward the broadcast message. We will discard. But if you use a router to divide the broadcast domain, it's too expensive. That's why we will use the technology of the VLAN, virtual LAN technology. And we can divide different departments in different VLAN, and within the same VLAN, they can directly communicate with each other. Also, the devices will forward the traffic out. So pay attention to the first one. If you want to use the VLAN, your devices must support VLAN, because some serious devices will not support the VLAN. That means only can use the VLAN 1. Everyone will use the same VLAN. The second one, when you use the VLAN in your network, we explain two interfaces, right? One is access interface and another one is trunk interface. So they have different function, and it will be used in different scenario. About the access interface, usually used to connect with the terminal and only can deal with one VLAN. For example, if I set this interface to become access interface and we have to deal with a VLAN 10, the other VLAN cannot be forwarded out of the access interface. So access interface usually used to connect with the terminal. And the second VLAN is the trunk VLAN, because between the switches, maybe we only have one link, but in our network we have multiple VLAN. So in this scenario, we need a new device, new trunk type, new interface type about the trunk. And about the trunk, we can allow multiple VLAN carry the VLAN ID and out. And then the different one is the trunk PVID, the native VLAN. This native VLAN is special. When we send out the message out, we will compare with the native VLAN of trunk and the message VLAN. If same, we will delete the VLAN and send out. If not same, we will directly send the message out with the VLAN tag. So these are two main devices, two main interface type in the VLAN. And another one is the VLAN ID. This one, maybe when you do the configuration, you will take this special to remember. Because about the VLAN ID, we only have the ID length is 12 bits. So when you create the VLAN, the available VLAN is from the VLAN 1 to VLAN 4094. Okay, the 4095 is reserved, and the VLAN 0 also is reserved. These two VLANs cannot be used. So when you create the VLAN, maybe you can create VLAN 2000, maybe you can create VLAN 4000, but you cannot create the VLAN 5000 because this is a limitation. So in some scenario, like your data center, only 4094 VLANs is not enough. So we will have the other technology like VXLAN, or maybe in some bandwidth scenario, we will use some super VLAN as the solution to solve the problem that VLAN number is not enough. But this technology not in this training. So yesterday we talked lots about these three parts: IP address, layer 2 switch, and the VLAN. Okay. So this is the first one. We have a brief summary of yesterday. Only 15 minutes, we talk something about the important one, but later maybe you are confused about some details. Last, I will send the video. You can check the detail. Okay, so this is the first three part. And today, the first topic, we will talk about the STP. Okay, the STP principle. So what is STP? Why we use STP, and how the STP can work? And if we want to configure the STP, what's the key command? So there are four parts we have to explain today, detail and to you. First, why we use STP? Because in our LAN network, local area networks, usually in our network, we not only have one switch. Okay, maybe in some bigger or medium office, you have lots of switches in your network. And in order to avoid the broadcast domain, broadcast storms, we hope in our network there is no path loop. As you know, if in your layer 2 network you have the loop, your network cannot work. That means finally everything will be discarded because your resources is not enough. This is very terrible scenario. But someone say, if we don't have the redundancy path, that means from source to destination, we only have one path. There is no loop. Yes, this is a good solution. But we also have another requirement. If this only one path, one link or one device is broken, this part of the message cannot work. So we also hope we can have some redundancy path, but avoid the loop. So how to meet this requirement? The STP will be used. The STP full name is Spanning Tree Protocol. Like the name, finally, if we use this protocol in our network, we will make the network like a tree. So about the tree, there is no loop, right? So after taking this course, I hope you can describe how the STP works. Okay, spanning tree protocol works, and what's the property of the STP, and what's the advanced feature of the STP. Of course, in this part, we will explain something of the command, how to give the configuration, and finally to select what's the rule of the STP. So this is the objective. And before we talk about the detail, let's have a topology to show you why we need STP. For example, now in your network, you have lots of devices, right? Maybe access switch and the distribute switch. And about the distribute switch, maybe you use the layer 3 function or maybe use the layer 2 function. And now we have the PC1 and the PC2. They in the same VLAN. So according to the principle of VLAN, if PC1 and PC2 want to communicate with each other, if we now have the topology and give the correct configuration of the VLAN and give the IP address of the terminals, finally they can directly communicate with each other, right? I send to the access switch, access for the message according to the MAC address table, and the distribute switch also will do the same process. But in this scenario, if here is a link is broken, what's the result? Can PC1 and PC2 continue to communicate with each other? Actually, it's not, right? Because the only path is broken. So in this scenario, when we can communicate again until we found the link is broken, and then to maybe change a new link. Maybe the interface is broken, we have to use this cable to connect with another interface. But maybe this interface is broken in the night and we are sleeping, right? So PC1 and PC2 want to communicate with each other immediately. No, cannot, right? So we hope we can have the redundancy backup. If we have another link, can directly connect with the access switch and with the distribute switch together. So in this scenario, if this link is broken, we still can use another path to forward the traffic again, right? To forward the traffic again. So this is the good solution we want to see. If one link is broken, we can continue to use the second path. But if we add this link, there is a problem. Let's say what's the problem here. According to this topology, we will find here is a loop, right? So someone say, if we have the loop, what's the hazards and what's the disadvantage? For our network, what's the result if there is a loop? So later we will explain this phenomenon at first. So now we have the requirement. We hope if one path or maybe one device is broken, we still can use the backup one. So if we connect a new link or maybe add a new devices, there maybe is a loop. And the first one, let's say if we have the loop, what's the loop phenomenon? Because the first step you have to check in our network there is a loop or not. Because now if I show you the logic topology, you can see easily, right? 3 switches and 2 of them connect with each other, so we can immediately judgment here is a loop. But in your network, maybe you have lots of switches and maybe they located in different places. So we have to, according to the phenomenon, to do the judgment, there is a loop. And if what scenario there will be a loop, the first one we can check the indicator of the switch port. If the indicator flashes rapidly in the same frequency, maybe there is a loop. And then we can see the MAC address table of the switches. If the MAC address and add, for example, I learn the MAC address and delete again. and learn again, delete again, or maybe to connect with the first interface and then connect with the second, and then to connect with the first interface again all the time. So maybe in this scenario, there is a loop. And the third one, if the switches is running out of resources and the logging option is exceptional, so this scenario maybe also happened the loop, there is a loop phenomenon. Because if there is a loop, the devices will force the traffic all the time until the resources is not enough. So this is a phenomenon we can judgment in your real network. And the second one, if we have the loop, what's the hazards? The first is link blocking, because if you have the loop and some terminal maybe send out the broadcast message, and this broadcast message will consistently flood in the layer 2 network. Very big number of broadcast message, because later I will show you the example, you will understand what's the big number of the message. And the second one, the host system response is slowly. Pay attention in your network, not only network devices, but also we have lots of terminals like the computer, right? And the broadcast message will be sent in the network. Also, the host will receive lots of message, because all the network devices flood the broadcast message at the same time. Also includes the terminal. I will receive lots of broadcast message all the time. So the resources maybe is not enough, especially about the CPU. Pay attention about the host. If I receive the broadcast message, I have to do the de-encapsulation. That means delete the physical layer bit and delete the data link header. And finally, you will find that this broadcast is not sent to you. But before you finish the decapsulation, you have to delete this message. You have to use the CPU to deal with this message. So this is the hazards of the host system. And the second one, for the layer 2 switches are slow to manage. So this also is a limitation, because the switch have to force the traffic all the time. But finally, this message cannot be sent out successfully. And the last one, we will impact on the CPU of the gateway devices. That means in your network, all the devices can receive the broadcast message. These resources will have a big influence. So this is a hazard. And then let's see what's the detail. I will show you an example and to let you see what's actually affect. For example, about here, there are 3 switches, right? 3, 2, 1, 2, and 3. And in the switch 1, there are 2 terminals belong to the VLAN 10. And one is PC1 and another one is PC2. At the beginning of the switch, if the PC1 and the PC2 want to communicate with each other, and the PC1 will send out the message. But about the switch, the first, if at the beginning we start the switch, the entry of MAC address table is empty, right? And then about the switch, when we first receive this message, because your entry is empty, so everything we will be think this is unknown unicast message. So in this time, if the switch PC1 send out a message, and this message source MAC address is PC1 and the destination MAC address is PC2. So about the switch 1 receive this message, we have 2 processes, right? The first one, we were to learn the MAC address. This is a learning process. And about the learning process, what's mean learning? We will add the source MAC address and connect with the receiving interface into the MAC address table, and then we will send the message out according to this table and depends on your destination MAC address. Because this is the first time we see the switch 1 MAC address table is empty, So one thing, we will add the source MAC address information, connect with the port 3, and we also divide the VLAN is VLAN 10. We will add this entry in the switch 1 MAC address table. This is the first step. The second step, switch 1 also have to help us to forward the traffic out. According to your destination MAC address is PC2 MAC address. I will take this MAC address and to match our table, right? But about our table now, we don't have the information of PC2 MAC address. That means this message is unknown unicast package. So about the unknown message, we will directly to flood the information. So the switch 1 will send the message out, includes interface 1, includes interface 2, right? In switch 2 receives the message. I also will add the VLAN information, add the MAC address information of the source part. The PC1 MAC address, VLAN is VLAN 10, and the port interface is gigabit 01. And another one, I also will flood the information of switch 1 gigabit 2 interface, and then to the switch 3. Switch 3 also will add this information. Of course, except this 2 interface, I also will flood to PC2, right? Except the receiving interface of gigabit 3, because I receive this message from here. And then we hope after the switch 1 flood the message, we can stop here, right? Because already according to the flood, PC2 received this message, but actually not. Switch 2 and switch 3 receive the message. I will forward the message according to the principle also. So let's say the continuous step here. About switch 2, I receive the message from PC1, from switch 1, this message, right? Because this, I will take the destination MAC address to match the MAC address table. I also found this is an unknown unicast message. So I will flood it. Flood it in this topology, maybe it's gigabit 2 to switch 3. And now let's say to switch 3. Switch 3 also will have the same process like switch 2. Because I receive a message, I will flood it. Then the next step, switch 2 and switch 3. For example, about switch 3. Switch 3 receive that message from switch 2. We will find the VLAN is VLAN 10. The MAC address is same, MAC address PC1. Pay attention, in MAC address table, one MAC address only can have one entry. So now I found about this MAC address, we have to connect with gigabit 02. So we will delete the first one and add a new one. The same operation of the switch 2. Maybe switch 3 will find now our PC2 connect with the other interface. So in your table, you only will keep one MAC address with the last port. This is option of 2 and 3, right? And then the next step, this is the learning process of the switch. And also, except the learning, we have to forward the traffic. So like the switch 2, I received now the message from switch 3, right? After update the message of MAC address table, then I will forward it. And then according to the destination MAC address, now I already know destination MAC address connect with gigabit 1, right? Because we already know this message. Although maybe we don't know this message, we will flood it. So this message will be sent to the switch 1 again. And then the switch 1 will do the update of the MAC address table. And the same process of switch 3, I will send the message from the switch 2 to switch 1 again. And then switch 1 will update again. So when switch 1 receives this message, I also will do the flood, right? I also will do the flood until the network resources is not enough. At this time, maybe PC1 send out a broadcast message again, and here we will see lots of broadcast message. And your MAC address table, the MAC address will be flashed all the time. So this is a loop effect. Okay, so this is the next step, right? Once the switch 1 receives a message from switch 2, I also will do the flood. Flood to switch 3, to PC1, and to PC2. So this is an effect. There have lots of messages in your network until your network cannot work. Okay, so this is the main difference with the switch and the router. If the router receives a message, in the period parameters, we will discuss the message, but layer 2 switch cannot. We will stop the forwarding until my resources is not enough. Okay, so there is a loop. So how to solve this problem? And it's a solution for it. Someone maybe say, in your topology, if you delete the link, for example, now you have 3 switch, right? How to avoid the link? If you directly delete the link, there is no loop, right? We can only force the destination to only pass. But if you delete the link, the other problem is if the main link is broken, the second link we cannot use. So we need a solution that in the normal scenario, one link will not work. So if one link not work, we will not force the traffic. So there will no loop in our network. But if we detect one normal link is broken, we can immediately to use the backup link to let this link to go to work to force the traffic. And about this solution, we hope the devices can do automatically. They can calculate by themselves and to decide which link will work, which link will not work, and detect the link health automatically. If one link is not broken, is not work, I can continually or maybe immediately to use a backup one. We hope we can have this solution. And this is the function of the STP, spanning tree. And if we deploy the spanning tree on our network, like this topology, we will choose one link to become the backup one and in the broken system. And the broken state means you cannot force the traffic at this time, but your indicator still is green. Your physically and your layer 2 layer, the state is up. And if one link is broken, we can immediately to let the broken stator to become falling stator and then to forward the traffic. So this is a solution of the STP. Okay. So what kind of this protocol like this topology? After we enable the STP protocol, finally we will design the one interface to block. And block means this interface will not force the traffic at this time. And then if one active link, now we detect this is disconnected or maybe have some other problems, then we can immediately to activate the blocked link and let this interface to help us for the traffic. So this is the function of STP. The first one, we can block the redundant link. And then after the normal link is broken, we also can activate the redundant link automatically. So we can use a backup link again. So this is a function. And then the next one, the key point is which interface should be blocked, which interface should be work, and which interface have to help us to forward the traffic. If we are not the design of the protocol, we hope in our network, the higher bandwidth interface can forward the traffic as much as possible, right? If lower bandwidth interface may be blocked as a backup interface, it's okay for us. So this is our main requirement. So about the STP, how to calculate the result, how to decide which interface should be blocked. Later we will see the detail. And before we see the detail, let's see some basic overview of this STP protocol. And about the STP, we have three types. One is STP, and another one is RSTP, faster than the STP, and the MSTP is multi-STP. That's because STP, we also about the STP, we say it can meet our requirement. For example, we can have the redundant link, and we also can have the logical blocking in our network. And about the STP, we also have some disadvantage because like the convergence is not fast enough. So we will have the RSTP. And about the RSTP, we also have some disadvantage. So we will use the MSTP. Okay. So this is the first one. And about the STP, we also have some IEEE protocols to indicate this STP. STP is IEEE AO2.3D, and ISTP is AO2.3W, and MSTP is AO2.3.S. About this one, you only know it is enough. You don't need to remember it. And later, let's see the principle and some basic configuration. We see about the STP, the main work we have to do is to select who will be blocked, who will be blocked, and who can help us to follow the traffic, right? This is the main part. And in the STP, how to do this determine, and we have some rules we have to know. STP is based on the SPA algorithm, shortest path algorithm. Of course, in this shortest, the parameter is the bandwidth. If higher bandwidth in our topology of the link and the lower cost value we will use in our network, we hope we can choose the lowest cost as the forwarding stator and help us to follow the traffic. So this is the algorithm we use, and you don't need to do the configuration. If we enable the STP, this algorithm will be used automatically. And the second one, the first parameter we have to know is the root bridge. And the root bridge in one layer 2 network, if we enable the STP, there is only one root. And one root bridge. And about the bridge means the switch, because before we use the switch, we use bridge in our network. So we also call the switch as a bridge. So the first step, we have to select who is a root bridge. And how to select, later I will show you the step. And the second one, except one root bridge, the rest of switch we call is non-root. Okay? And about the non-root, one switch, one RP, root port, one root port. And about the root port, we will select the lowest cost value and connect with the root. And then each link, we have to decide one designated port, one DP. Okay, this is a DP. And the rest of ports will be blocked as an AP, alternate port. And about the blocking interface cannot work. So, for example, in this topology, there are three switches, 1, 2, 3. And who will be the root? Who will be the non-root? And what's the rule of the interface? Should it be RP, DP, or should it be AP? We will compare the parameter with each other. For example, my priority is higher than you, and I should be the root. And my interface should be DP and to follow the traffic. So we have to compare these parameters with each other. And how to receive this information and do the comparison? We will use the special message only for STP. And this message we call is BPDO. This one is very important. Bridge Protocol Data Unit. This is a BPDO. And after we enable the STP in our network, all the devices will send out the BPDO. And in the BPDO, carry all the parameters of the switch. For example, your priority, your MAC address, something like this. And when I receive it, I will compare with you and finally to design the rule and the status of the interface. So this is the basic overview of the switch. And about the BPDO is very important because everything will be added into the BPDO and the other side receive this message, compare this information, and finally we will decide who is root, what's the interface type. And about the BPDO, there are so many parameters. And the right one is I use a Wireshark to get one example to you. The STP is encapsulated into the IEEE L2 the 3 Ethernet. This is the data link layer protocol. And we can focus on the STP some parameters like this. And the protocol identify and BPDO type flags, something like this. And also we have some age to limit the STP to finish the convergence, something like this. So about this part, I will explain for you some detailed parameters. Okay. The first line, because later when we select who is root and maybe what's the interface type, all the message from this link, from this date, and maybe you can focus here, and later you can understand better. The first one is protocol identifier. It has 2 bytes and always 0. This is the fixed value. And the second one is a version. It have 1 byte. And the different value indicates this BPDO from different type. We have 3 type, right? 0 for STP, 2 for ISTP, and 3 for MSTP. So if you enable the MSTP in your network, when you check the version, this will be 3. So this switch will do the mechanism according to the MSTP mechanism. Will not only consider about the STP. So this is the value of the version. And the next one is the message type. This part is very important for us. It has 1 byte. And if the value is 00, that means this is the C BPDO. C is a configuration BPDO. And the configuration BPDO is used to establish and maintain STP topology. What's mean? For example, about the STP, we have 2 main steps. The first one is to calculate who is root, what's the interface type, RP, DP, or AP. This is the first step, right? The second step, if one link is broken, we have to immediately to enable the backup interface to help us to follow the traffic, right? How to make the speed faster and how to do the other process. Except the CPBDO we need to do, another one we call is TCN BPDO, the topology change network BPDO. Only the TCN BPDO only will be sent out when the normal link is broken. So this BPDO only is converting the topology changes. So these are 2 types of interface, 2 types of BPDO. Pay attention about this one. About the TCN BPDO, the value will be 80. And the next part for the flag. The flag have 1 byte long, and 1 byte long means we have 8 bits. And the lowest bit is TC flag, topology change. The most signal bit is TCA, topology change acknowledgement flag. So this part also will be connected with the TCN BPDO together. Pay attention. If we make the TC flag to become 1, or TCN bit to become 1, both of them between to the C BPDO. Okay, this also is a config BPDO. And this is different with the TCN. Later, when we talk about the topology changes, I will show you the detail. And next part is the root ID. 8 bits indicates the RID of the current root bridge. And finally, every switch send out the BPDO, the root ID will be same. Only is the root bridge ID. And it has 8 bits long. The first 2 bytes is the bridge priority. And the last 6 bytes is the MAC address of the switch. So this is a root bridge. And the next part is RPC, root path cost. And it has 4 bytes long, indicates the cost value of each link. And it depends on your interface bandwidth. 1 gigabit interface, the cost value will become 4. 10 gigabit interface, the cost value is 2. Pay attention about this part. Okay? So this is the first one. And the second line for the bridge ID. Bridge ID is whose ID send out the bridge message. Pay attention. Some scenarios, the root ID and the bridge ID will be same. What's the scenario they will be same? Who can give me some answer? In which scenario this ID will be same, these two ID? Root ID and bridge ID will be same. No answer? If this BPDO created by the root bridge, the root ID and bridge ID will be same. But if non-root bridge creates the BPDO, the root ID is the root bridge ID, but the bridge ID is the non-root bridge ID. So this will be different. And the next one is the port ID, 2 bytes. And the first byte, the default value is 128. And this port ID will finally to limit what's the rule of the interface. Okay. The next one is a message aid. The 2 bytes indicates the survival time. For example, about the BPDO, we will send out every hello time. By default, the hello time is 2 seconds. That means the root bridge will send out the BPDO every 2 seconds. And once the other receives the BPDO and will wait. Over some time, I will not receive this BPDO. I will think my upper layer switch is broken. So I will do the calculation again. So these are the time. And the max age is 20 seconds. And then the forwarding delay is 15 seconds. So what's the scenario of this message will be used? Later, I will show you the example for you to understand better. And now let's see the process, how to select the root bridge and how to define the interface status. The first one, we have to select the root bridge. And about the root bridge, we will compare the bridge ID to select. The first one to select the lower priority will be better. If the priority is same, we will compare the MAC address. The default priority is 3276, something like this. So, like this example, if here we have 3 switch, 1, 2, and 3, and each switch we have the priority and the MAC address, right? This will be indicate the bridge ID. According to this 3 bridge, who will be the root? Who will be the root bridge? Can you give me some answer? Switch 2. Yes, it's correct. We will compare the priority at first. Smaller one will be better. Switch 2, the priority is 0, but switch 1 is Switch 1 is 32768. This is the default priority. This means when you enable the STP and you don't give the configuration to change the priority, this is the default priority. And the next one, Finally, we can compare to select the switch 2 will become the RP, and 1 and 3 will become non-root bridge. Okay, so this is the first step, very easy, right? The second step, we have to select the RP, root port, and pay attention about the RP. Only non-root bridge, we have to select RP, and one bridge, one RP. Okay, so how to select the RP? We will compare the cost value, and the cost value is compared from the switch to the root. For example, here 1, 2, 3, and now we already know switch 2 is root, right? And later I will show you the different cost value of the link. By default, the cost value will be calculated by the bandwidth. So now I will show you cost value of each link like this one. So about the switch 1 and switch 3, which interface will be the root? Will be the RP. First, let's see the switch 1. About switch 1, we have two interfaces, right? On these two interfaces, we have to select one port to become the RP, and the left one or the right one. We will compare with the cost value at first. So about the left one, the cost value is 10. But about the right one, the cost value is 50. So finally, the left one will become RP. The same result of the switch 3. Two interface. One directly connect with switch 2 and another one will connect with switch 1. According to the cost value, this link is 30 and this link also is 30, right? If the link cost value is same, then we will compare with the bridge ID. Okay, compare with the bridge ID. And about the bridge ID of the switch 3, one bridge ID from switch 2, the priority and value is like this value of switch 2. But another one bridge ID from switch 1, the bridge ID is this one. So compare the bridge ID. We also will select the smallest one to become the better one. So finally, we will select this interface to become RP because the root bridge ID has a best priority. So compare with these two parameters, we will select what means RP. And the third one, maybe in some scenario, we will select what's according to the port ID. For example, if between the switch 2 and the switch 3, there are two links, we will find the cost value is same. The bridge ID value also is same. We will continue to compare the port ID, and the smallest one will be the better interface. So this is the second step of the RP. Okay, and the next one for the DP. The DP select all the link is achieved by compare the fields BPDU message and then to select the DP. One link and the interface has higher priority, we will select this interface to become the DP. One link, at least one DP. Now we know the switch 2 is root, and switch 3 and 1 we already have RP, right? So this link, one interface already RP, so the other interface will become DP. The same principle of this one is the DP. And compare of this link, which interface should be DP? We have to compare the cost at first. And about this link, one cost is 10 plus 20, this is 30. And another one is 30 plus 20, this is 50. So finally, these two interfaces will become DP, and this interface also will become DP because the cost value is smaller. If the cost value is same, we will continue to compare the bridge ID. And finally, if bridge ID is same, we will compare with the post ID. So now we define who is DP, who is RP, right? And finally, all the ports of the DP and RP were blocked to be the AP, alternate port. Okay, so finally, this interface will be blocked. Block means this interface will not follow the traffic if all the other link is working. Until one link is broken, for example, this link is broken, we will enable this interface to help the devices follow the traffic. So this is the 4 steps, how to calculate the spanning tree and finally to avoid the loop. Okay. So now we already decide the rule of interface, DP, RP, and AP, right? And now if the devices can be forwarded out or not depends on the status. And there are 4 status of the switch: blocking state, and listening state, and learning state, and forwarding state. Finally, only the forwarding state can forward the traffic. Blocking state means we select the interface, and according to the calculation, finally the interface is AP, and the AP will located in the blocking system. In this system, we can receive the BPDU from the other switches, but we cannot send out the BPDU, and we will not forward the customer message. So we don't need to learning MAC address table. This is blocking system. Pay attention, blocking system is the interface system of the switch, not means this switch in the blocking system. This is different. This switch still can learning MAC address, but in your MAC address table, you only can see the interface in the forwarding status. The second one is the listening status. And in the listening status, we will stay with 15 seconds. And in this data, we will finish the STP convergence in this data. That means someone finally will be decided to be AP back to the blocking state. And someone may be selected to become RP or DP. We will go to the learning state to begin to study the MAC address. And about the learning state, we also will stay with 15 seconds. And in this time, we only to do learning MAC address. Okay, to do learning MAC address table. And finally, 15 seconds later, the interface will become the forwarding state and then to forward the traffic out. So about the blocking port, we only will keep the state of blocking. And in this data, we only can receive the BPDU. We cannot send out BPDU. We cannot learn MAC address. We cannot forward the traffic. And these 2 status we call is media state. In this data, we will not forward the traffic until the interface to become forwarding. So there is the biggest problem of STP. If one interface to be DP or to be RP, you have to wait at least 30 seconds, and then you can forward the traffic out. So this is a very long time for the customer. So this is a port state. And now we will have a real case for you, because about the example, I only show you 3 switches, right? And how to select who is RP, how to select who is DP, and something like this. But in your real network, maybe they are more complex. For example, like this topology. And the right one is the parameters of the priority of the switch and the MAC address of the switch, something like this. And we also change some port priority of the switch. So about this part, according to these parameters, place to analyze who will become the RP and all the RP, who will become the root bridge, and what is the RP, what is the DP, what is the block port. So maybe now 1 minute Please see the detail of the priority parameter, and later we will do together.
Так, здесь вообще.
A little complex. Okay, maybe you can see the parameter now, and later I will ask you one by one to decide the state together. So now everyone sees the topology successfully, right? Because there are so many loops, we have to enable STP and to calculate the result. Of course, in the real network, you only need to enable it enough. You don't need to know who is root, what's the state of the interface, because the switch will calculate automatically. But maybe you have to know. For example, I think the switch 1 has a higher reliability and has higher performance. I hope all the interface can follow the traffic. So in this scenario, you need to change some priority or change some parameters in the switch. Okay, so you have to know the result. Otherwise, for example, if you change the switch 5, the priority to become 0, this switch will become the root bridge, and the other high bandwidth interface maybe will be blocked. This is a waste of the bandwidth. So the first, according to this parameter, who can show me some answer? Which switch will become the root bridge? Who is a root bridge? 1, 2, 3, 4, 5, 6. Switch 3. Really? Do you still remember what's the default priority value? Oh, really? Okay, our default value is this one. 3276, yes, 32768. This value is the default value. So how to select the root bridge? We will compare yes, good, switch 1. We will compare the priority, and all 3, 4, 5, 6 is the default value. So we will select the smallest one. Smallest one is switch 1, right? So finally, switch 1 will become the RP, will become the root. And the second step of the non-root bridge, we have to select one RP for one switch, right? So about switch 2, who will become the RP? 46, 48, 47. If all link, now we use the cost value to become 10. All the links, the value is same. About switch 2, who will become RP? RP is the root port. We will select one switch, one RP. Now let's focus on switch 2. Switch 2, the RP should be 8, the interface 48, right? Because the cost value is smallest is 10, right? The other link connect with root is more than 10. Okay, so about the switch 3, who will become the RP? 23, 24, or 1? Yes, 23. This will become the RP. And about the switch 4, who will become the RP? 23, 24, 22, 1 or 2? Yes, it's correct, 23. How about the switch 5? 24, 23, 22, 1, 2. Yeah, it's 23, correct. How about 6? It's a little difficult. 1 or 2 will become RP. One, someone say port 1 will become RP. Anyone select port 2? No one? Okay, let's see the switch 6. Okay, switch 6, first we will compare the cost value, right? But two interface, the cost value should be same. Left is this one, and the right one also is this one. We have two link. So if cost is same, the second one we will compare the bridge ID. These two interface, the bridge ID, both of them is switch 5. So the bridge ID also is same. Then we will compare the port ID from the switch 5, the left one and the right one. The default priority of the port is 128. 128. And about the right one, special is here. Of the topology switch 5, we change the second interface, the priority to become 16. So compare the priority of the interface. The second interface has a higher priority. So finally, we will select the port 2 as the RP. Okay, so let's see the process. Switch 1 is the root, and 40 is RP, 23 RP, 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 and RP, right? So this is the final RP we choose on each switch. And then each link, one link, at least one DP. And about the DP interface should be in the link has a better has a best BPDO on the link, and this interface will become the DP. So the switch 1 has the highest priority. So all the interface will become DP. And then let's see the other switches. About the switch 2, compare with this link. Switch 2 interface will become DP. That's because compare with the cost value to the root, these are same, right? One link. And then we will compare the priority of the switch 2 and the switch 3. Switch 2 has higher priority, so this is a DP. And then the same process, this link, we will select this interface will become DP. And this interface will become DP. And the switch 4, this interface is DP. This interface is DP. DP and DP. Finally, the rest of the interface will be blocked. Like this one. Okay, so this is a calculation of this topology. Of course, if you have the scenario to do this practice, you can change the parameter according to this part, and finally to check the status of interface. And then we can compare with this topology again. And in this scenario, pay attention, we also have the other problems. We can define all the interfaces, the status, the rules, should be DP, RP, or the other status. But pay attention about the last one. If here we connect with a hub, these two interfaces should be blocked or not, because according to this topology, we can find there is a loop. But about the STP, we cannot solve this problem. So finally, if we define every status of the link, finally the topology will be like this. And all the link will be no loop because we broke lots of interface. But except this part, there still also have a loop. And how to solve this problem? We have to use another technology. We call it RLDP, Rapid Link Detector Protocol. And about this part, this technology we will not discuss here. Normally in our network, if you don't use the hub, STP is enough to calculate the result and to avoid the loop. It's enough. So this is the STP cases. And the next one is the TCN BPDO detail. According to the CBPDO, we already can calculate the result to calculate which interface should be blocked or which interface can work on the network. And another one is if the normal link is broken, how to enable the blocking interface and to follow the traffic. So if one normal link is broken, the backup one should be work. This is the first step. The second step, you have to refresh your MAC address table because according to the previous MAC address table, maybe you will force the traffic out and there's some mistake. So how to let the devices to do the convergence faster and how to make the MAC address table refresh faster because by default your MAC address table refresh you need 5 minutes. In this scenario, we will use a new package we call it TCN BPDO. And TCN BPDO is another type of BPDO. We also can call this is TC message. If one port on the bridge transfer to forwarding state and to another state, of course at least one DP interface, or maybe changing the forwarding state to become learning or blocking state. In this scenario, we will send out the TCN BPDO. And about the scenario, let's say, the TC message usually generated by this situation. The first one, if link or devices failure, this will trigger the STP to create the TC message. The TC message is the same meaning of the TCN BPDO. Or maybe STP configuration parameter changes also will triggers. A port may be connected to the terminal and the STP enabled, but we don't configure as an edge port. What mean edge port? Later we will explain for you. Or maybe some attack TC message from the customer equipment also will let us to refresh our MAC address table and calculate the topology again. So let's see the process. For example, now according to the TCN BPDO, finally we are ready to select who is root, and some interface already be blocked. And in some scenario, now the link of the switch 3 and switch 2 is broken. What's the step? First, switch 2 and switch 3 will be the first switch to find the link is broken, right? So this is the responsibility of these two switches to tell these things to everyone. Now the link is broken. We have to do the convergence again and the place to refresh the MAC address. So these are two things we have to do. And how to meet the requirement? The switch 2 will send out the TCN BPDO message, and this message will tell the upper switch, now my link is broken. And then the switch 1 will give a reply. This reply means, okay, I received your message, and I have to give you the acknowledgement. And pay attention about the acknowledgement. This acknowledgement is the configuration BPDO, CBPDO, but the special one is a flag. In the flag bit, the acknowledgement bit will become 1. The function is to tell you your TCN BPDO message I already received. And this CBPDO will be sent out every 2 seconds. That means now I immediately create the TCN BPDO to switch 1, and switch 1 will give the reply after 2 seconds, after the next BPDO I send to you. And then the switch 1 will do the other things is, I also will transfer this TCN BPDO to upper switch, because who can tell us now let's refresh your MAC address table? This is the power of the root. So the TCN BPDO will be transferred to the root one by one until the root receives this message. And later, the root will receive this message and send out a BPDO. This BPDO is configuration BPDO. And in this BPDO, we will make the flag TC bit to become 1. And this function is to tell everyone, please shorten the time to refresh your MAC address table. Pay attention about this part. And when the switch 1 receives this BPDO, I also will transfer to everything. Transfer to everyone, and your MAC address should be refreshed. So we can modify the MAC address table aging time from 300 seconds to forward delay. And by default, the forward delay is 15 seconds. Okay, so this is a whole step. So if one link is broken in our network, we will create the TCN BPDO, except the link directly connects the root. If this link is broken, pay attention. If this link is broken, the root will directly send out the BPDO carries the TCN bit directly to tell everyone, please refresh your MAC address. So this is the function of the TCN BPDO. Okay. So now the root will send the BPDO to make the TCN set to 1 during the max age and forward delay time, 20 and plus 15 seconds. And then shorten the MAC address aging time from 3 seconds to 15 seconds. So finally, the network can use the new link, and to forward the traffic correctly, maybe we need 15 seconds. Okay, 50 seconds. So this is a TCN BPDO example. And let's see the recovery time. Someone maybe say now if one link is broken and the new link can be used at the same time, 50 seconds. But some scenario, we only need 30 seconds is enough. For example, about the left one, directly connection failure. Here is the root, and we are ready to decide the right one to become the AP, right? And all the traffic will use the left one. Now, if the normal link is broken, okay, we will trigger the STP convergence, and the time is immediately because now the root directly found the problem, and the switch one is RP, one is AP. Now my RP is broken. I directly know it, so I can directly make the AP enter the learning station, right? The learning station, and then to enable the change the status, so the time will become forwarding to and multiply 2, because we have 2 status we have to do. One is learning and another one is listening. And learning to listening and listening to learning, learning to forwarding, each one will be 15 seconds. So in this scenario, at least 30 seconds we have to wait. And another one, if non-direct connection. Now, for example, switch 1 have the RP, have the DP, and now we're blocking the switch 2. If in this scenario, the switch 1 link is broken, right? The switch 1 will to find, because my connection with RP is down, so the switch 1 will think, I am the new root, because he will think the root on the network, I cannot do the communication with him. I will be the new root. So I will send out the BPDO to switch 2. I will become the new root. but the switch 2 will ignore it because I know in our network the root is exist. So when we will find the link is broken until the maximal age. The maximal age is 20 seconds. So 20 seconds later, I will make the interface from to blocking to listening and then to the learning. So in this scenario, if one link is broken, at least 50 seconds, this interface can in the learning forwarding and to forward the traffic. So this is the biggest problem of STP. At least 30 seconds later, you can use the AP interface to be forwarding the traffic. This is STP. And some basic configuration, maybe we have a break and 15 minutes later, let's come back to see the configuration. And later, we also will discuss some advanced feature of the STP. About STP, there are lots of parameters we have to know, but the configuration is very easy. So 15 minutes later, let's come back, okay? Now maybe let's continue next part. So I will ask one question for you, like the speed and the detail of today's STP is okay for you? Maybe you will think it's too much for you or not. This explain detailed information for you is ready for you. Can you accept it? No one answer? Really? Yes? Okay, because about the STP, we have lots of parameters to explain. And later, when we talk about the next technology to you, okay, let's see the basic configuration. Because if you know the principle, you will understand the configuration better. And of course, we have lots of technology to provide the redundancy backup and also can avoid the loop. We have lots of technology. STP is one of them. And we also have the link aggregation. We have VSU. But you have to know the principle and then you can select which scenario is best solution in your network. Because about the STP parameter, we have lots of, but the configuration is very easy. Okay. The configuration, the key point, you have to start the STP protocol and you can change some priority to decide who is the root or what's the state of the interface. And the key command how to start the Spanish tree protocol. The first one in the global configuration, you have to enable this protocol. The command is Spanish tree. And then you have to select which mode you will use. Spanish tree mode STP. Of course, we have another mode like the ISTP and MSTP. And then you can use the command to change the priority. Spanish tree priority like this one. But pay attention, the bridge priority is increment of 4096. The default value is 32768. Okay, because we have 8 bytes of the bridge ID, right? But only the first 2 bytes is used for the priority. So the totally long we have 8 bytes, 64 bits. So we have some limitation. You can change the priority to become 0 to become 4096, but you cannot change the priority like 4000. So this is a limitation. And pay attention, another one for priority value smaller is better. Okay. And another one, this is an explanation why we configure the priority only can be integer a multiple of 4096. because lots of bits belong to the micro address. Okay, 2 to the power of 12 is 4096. And another one, you also can modify the port cost value and the port priority to determine the rule. For example, I think the bandwidth of this interface is better, but according to the principle, finally the interface will be blocked. In this scenario, you can directly change the cost value or maybe change the port priority to change the result. And the key command is here. The cost value you can change in the special interface Spanish tree the cost value from 1 to lots of value. And about the cost value also is smaller is better. And about the interface priority, the command is Spanish tree port priority and to change the value. But pay attention, the default value is 128 and also have some limits will be increment of 16. So you can create the priority to become 0, 16, or maybe 32, something like this. You cannot use the value to become 50. Okay, after we finish, we can use some commands to check the result, like show Spanish tree summary. Okay, and here is an example. We have 3 switches, and 1 and 2 is a call switch, and the switch 3 is an access switch. So usually the call switch performance is higher than the access, right? So if we have some link, we need some interface to be blocked. We hope that the access interface can be blocked. And the other interface of the caller, we can follow the traffic as much as possible. So in this scenario, you can directly to change the priority to finally determine the interface rules. The switch 1, you can enable the Spanish chain at first and change the priority to become 0. About the switch 2, we change the priority to become 4096. And about the switch 3, you only enable the Spanish tree is enough, right? Because we have the default value of the priority. And pay attention, you have to check your devices because some vendors default Spanish tree protocol is STP, but some vendors default STP is MSTP. Pay attention about this one. And also the second one you have to know, some devices we will default enable the STP protocol, but some devices is disabled. So if in this scenario your device is by default is not is disabled the switch, you directly use 3 cables with each other, there is a loop. Okay, so pay attention about this part. You can directly to calculate switch 1 and switch 2 and then to connect the third link. Otherwise, there is a loop. Okay, so this is the key point we have to know. And another one, after we finish the command, you can use the command to do the check. Show Spanish tree summary. And here you can see lots of information. First, what type of Spanish tree protocol you use? Here we will use STP. And what's the root ID priority is 0. Maybe this switch is not the root bridge. Pay attention about this part. And the MAC address of the root ID is this one. And this bridge is root or not. Here we will directly to let you know. And the hello time is 4 seconds. For delay is 18 seconds. And the max age will be 20 seconds. So pay attention, these 3 parts. The parameter is changed. By default, the hello time is 2. For the delay is 15. And the max age is 20. Pay attention if you change the time. For example, about this part, your convergence time will be longer. That means maybe if we use the default value of the time, 30 seconds is enough for us to finish the convergence. but now you at least to waiting 36 seconds, okay? Double of the forward delay. And of course, if one link is broken, you will wait a long time. But in this scenario, if your network is stable and never maybe the link will be broken, it's better because you every 4 seconds to send out the BPDO one time. If the hello time is 2 seconds, you also need the resources to transfer the BPDO within 2 seconds. Every 2 seconds, you have to send out a BPDO again. So depends on your real network to make the time is longer better or shorter better. Okay, so this is the time difference. So the first part about the route ID and the address ID is the route bridge. And the next part of the bridge ID and the MAC address is this switch information. But here, these two MAC addresses are same because this switch is a route bridge. But if this switch is not a route bridge, maybe the MAC address will be different. Okay, and this time also is same. The hello time, the forward delay, and the max age. And here are the interfaces we already enable the spanning tree. Now we have two interfaces spanning the tree. The rule of this interface is DP. This is a short writer of the name DP, okay? Because this is a root. By default, usually every interface of the root, the rule will be DP, no RP, right? RP only exists on the non-root bridge. And now the status is forwarding, and the cost value is 20,000. The priority and the operate edge is false, and the type is P2P. So these are some points you have to know because in your network, if your spanning tree still in the processing process, and in the convergence processing, the state maybe you will say is listening or learning, but finally only the forwarding state can forward the traffic successfully. Okay, so this is the command, how to check the spanning tree information. And the second part is the advanced feature of STP technology. Pay attention about this part. Advanced feature not means ISTP or MSTP. ISTP and MSTP is the other protocols. And on the STP, we also have some advanced features. The first one is port fast. What means a port fast? Because in our network, some interface is special. Why we need to make this interface to wait a long time, right? We wait 15 seconds to make the interface to become listening to learning, and also continue to waiting 15 seconds to let the data from learning to forwarding. Why we need to wait so long time? Because if you let the interface forwarding immediately, maybe in your network there is a loop, right? So we have to give so much time to let the devices to calculate and finally to get a tree to avoid the loop. But in some scenario, we hope this interface we will know this interface never loop, right? Because like this topology, if we use the interface to connect with computer will impossible to have the loop because I only send the message and receive the message. I will not forward the message from the computer. So in this scenario, we hope if we have connected with some computers, they can immediately to forward the traffic. Otherwise, waiting 30 seconds is too long for us. So in this scenario, you can directly to make this interface as a port faster. So in this scenario, if computer directly connect with the interface, they can enter the forwarding state immediately without waiting. And the command is enter the interface spanning tree. port faster. Okay, maybe some vendors say this will be the edge port, the same meaning. Okay, so this is a port faster. It's very useful. For example, when you do the plan about the access switch from the first interface to the 10 interface, you design the terminal will connect with them. So this interface you can make to become the port faster. And pay attention, if a port with this attribute and also receives a BPDO, the port will enter the forwarding state after 2 forwarding delays. This mechanism is used to avoid maybe I tell the engineer the fifth interface will be connected with the computer, but he forgot and connect with a switch. So if the switch connect with this interface and you let the interface immediately to become forwarding, maybe there is a loop. So if the interface receives a BPDO, this attribute will be lost. Okay, this attribute will be lost. Of course, if you connect with a hub or maybe connect with a switch but not enable the STP, this switch also will sync. Now a computer connect with us. How to charge that I have to enter the forwarding state immediately or not? Depends on I receive BPDO or not. Okay, so this is the first one. And the second one is BPDO guard. BPDO guard is used for once a port should not receive the BPDO. For example, I already make the interface to become the port faster port. And in this time, I receive the BPDO message. If you only have the port faster attribute, we will waiting 30 seconds and then enter into forwarding delay state, right? But if you enable the BPDO guard, and this interface receives the BPDO, and then I will immediately shut down, and to make the state to become error disabled state. And in this mode, the interface can send out BPDO to finish the convergence, but cannot working to forward the traffic, avoid the loop. Okay, and we have two modes to do the configuration. One is global mode enable, and another one is the interface enable. If we enable this function on the global, and then you also add the port faster on the interface, all the interface will be get this feature. But the normal interface don't have any effect of this feature. So this is used to avoid by the illegal user causing the network topology to change. Because if you connect with an illegal user and send out the BPDO, all the network will do the calculation again. And before the convergence successfully, the network cannot forward the traffic. The result is the customer maybe cannot visit the internet. So this is a function. And this is a command, span tree port faster BPDO guard default. And another mode is interface mode enable. We can turn on the BPDO guard for a single interface. Of course, this interface is independent of whether the port faster is configured or not. And in this case, if we only add one interface to be BPDO guard, when this interface receives a BPDO, we also can make the interface to become error disabled. Although maybe this interface never adds the config of port faster. So these have different influence, but the result is same. The state, the interface will be in the error disabled state. And the command is enter the interface and add the span tree BPDO guard enable. Okay, and how to recover the enable disable. For example, now we will find this interface is a normal interface and we hope they can work normally. If you choose the interface name mode enable, You have to shut down and no shutdown, and then the interface can work normally. In the global mode, you have to use a special command. Arrow disable recover enter 300 seconds. So this is the command. And the next one feature for the BPDU filter. And the BPDU filter can filter the BPDU received or sent out on the interface. That means you can think if you add the command of this interface, and this interface will not join anything of the STP. Okay, this is a special interface of the switch enabled STP. And in the global mode, turn on this feature. The port faster enabled will never receive and send out the BPDU. If the port faster receives the BPDU, then this attribute will be discarded. Also, the BPDU filter will be disabled automatically. And the command is here. And if you use the global mode, only have the influence for the port faster. And another one for the interface mode. If you directly enter the interface and use the command spanning tree BPDU filter enable, and then if the interface neither receive BPDU or send out the BPDU, like turn off the STP function of interface. But pay attention, if you turn off the STP function, that means this interface is a normal interface. If I use the cable to connect with each other, I can directly forward out. I don't care about there is a loop or not. I also don't care about there is a redundant backup link or not. So this is a BPDU filter. And another one is a TC protection. This one also is very useful. Do you think what's function of the TC BPDU? Anyone can remember what's the function of the TC BPDU? We see if we deploy the STP, right? We have two types. One for the CBPDU, configuration BPDU, used to finish the convergence. That means decide who is root bridge and what supports to become RP, to become DP, to finally blocked to become AP, something like this. This is a convergence process. And the second function is when the normal link is broken, we need the technology to immediately tell everyone one link is broken. We have to do the convergence again, reconvergence. And another one, please to let everyone know to refresh your MAC address table because your MAC address table is wrong from the normal link, right? So we will use the TC BPDO, means we will make the flag of TC to become 1. This also is a configuration BPDO. The root bridge will send out the TC BPDO to let everyone to refresh your MAC address table and short the refresh time from 300 seconds to become 15 plus 20, 35 seconds. So that means if I receive TC BPDU, I will delete all MAC address table and learning again. Okay, and learning again. So if someone in your network, I am the attacker and I create the TC BPDU sent to your network to let everyone you have to delete MAC address. You have to delete MAC address all the time. That means maybe all the time everyone's MAC address entry is empty. So when I receive the message, I will flood. Okay, so this is the influence. And if we enable the TC protection, this is used to avoid the option being frequently done. So you can give the special resign. For example, if we enable this function, only one deletion operation will be done within usually 4 seconds. That means maybe within 4 seconds, I receive 10 times to let me delete the MAC address table, but I only delete one times. But after 4 seconds later, maybe I receive the message again to let me delete the MAC address table. I will delete again. So we can reduce the frequency to refresh your MAC address table and the ARP table. Okay, because about this table, if it's empty, about the MAC address, we will do the flood. About the ARP, if your ARP table is empty, maybe I will send out lots of ARP packets to ask the destination what's your MAC address to let me know again. So this is the feature. And the command is in the global, enable the spanning tree TC protection. Okay. So this part about the STP, and here is a question. Which of the following description of the STP interface data is incorrect? Do you still remember about this part? So who can show me the answer about this question? Which one is incorrect? D. If the block interface does not receive BPDO within a certain time, it will automatically switch to listening data. Yes? Someone say this is wrong? Yes? Okay. So maybe who can let me know why do you think this is incorrect? Maybe for the first guy, fragile. Can you open your voice and maybe can you let me know your idea? Why do you think the option D is incorrect?
Hello, Emily.
Yes.
Mm, Because the block port when does not receive the BPDU for a certain period of time.
Uh-huh. You
Mm,
mean your block interface will never receive the BPDO, right?
yes, the block interface cannot be changed to listening port or the uh, another ports because block interface always remain the block
Hmm.
interface.
Okay.
That's why.
Okay. Thank you for your answer. But this question should be A. So maybe I have to give you a review about this status. Do you still remember
Okay.
about this part? Blocked port, right? And RP and DP. In the blocking status, we can receive BPDO. And this also is a parameter I'm waiting. Because every 2 seconds by default, every 2 seconds the root bridge will send out the BPDO and every non-bridge root bridge will forward the BPDO. So I'm waiting. And one the blocked port can be RP can be DP. That means some normal interface is broken and I have to become forwarding to help the traffic. This is a function of redundant, right? So in this data, I can listening and I also will wait. If everything is okay, I can receive every 2 seconds. But if I cannot, I also will not immediately enter to the next state. I also will wait because maybe I consider that some BPDO in the network forwarding is lost. But this is the correct, is the normal environment. But until the pre-read time, 20 seconds later, all the time I cannot receive this message, I will think there's some mistake in the network. So I will continue to become listening, learning, forwarding, and make the interface to become the forwarding interface. So the option D, let's come back. If the blocked interface does not receive BPDO within a certain of time, it will automatically switch to listening state. This is correct. Okay. This is a scenario like this one. If this link is broken, yes, this interface will never receive the BPDO from switch 1 again, right? Because switch 1 has lost communication with the root. So until the after maximal age, 20 minutes later, 20 seconds later, I will automatically to become listening and continue to do the convergence. So option D is correct, but option A is wrong, right? I think now let you see the table. You will find option A, block interface can listening the BPDO but cannot forward out. So this is a mistake of the option A. Everyone is clear here? Yes, it is incorrect. Okay. So about this topic, we have lots of time to explain what is spanning tree, right? And you have to remember what's the main function of the spanning tree. Because in our network, we hope we can get the redundant link in the network. If one normal link is broken, the backup one still can force the traffic. So this is the main one. But if you add the devices or add the link, we also hope we can avoid the loop. So about the STP, if we enable that, automatically some interface will be selected as an L port and then to be in the blocking system. Okay, and another one, the second one, we explain the detail how to select the root bridge, how to select the RP, DP, and blocking other ports. Finally, the topology will be like a tree. There is no loop. But if you want to make the network convergence faster, once the normal link is broken, we also will use another message we call it TCN BPDO, right? To make the MAC address refresh faster. Okay, and the last part we talk about some advanced technology feature like the port faster, BPDO guard, BPDO filter, and TC protection. So that's all about the STP.